So texture of igneous rock, there is a mutual relationship between different grains within the igneous rock. Simple एक term में हम define कर रहे हैं what is the texture. It is a mutual relation between among grains it is because different cooling property or cooling behavior of the magma. So during cooling of the magma can cool slowly up to final crystallization, or the cooling may vary. So that cooling will produce different grain size or the nucleation rate that under cooling they all will help to give you a different grain size within an igneous rock. So different size distribution within igneous rock that depends upon different cooling condition. So it will define the mutual relation whether the igneous rock that consists of all equal size grain or suppose or all unequal size grain or different shape of grains. So it can be studied under different, that is your crystallinity, granularity, that all you know at least what is crystallinity. It is the degree of crystallization, that is hollow crystalline, semi crystalline, hollow hyaline. What is hollow crystalline? Consists of all crystallized grain. Consists of all crystallized grain. Hollow hyaline consists of glassy matter. Hemicrystalline is partly crystal, partly glassy. Similarly, on the term of granularity, with the define the size, so where we will classify it into two types. One is your phaneric, another is aphanetic. So texture of igneous rock can be defined by the following terms. You can say one is crystallinity. It define the degree of crystallized grain within a rock. There are three types, hollow crystalline, hemicrystalline, hollow hyaline. Then granularity, define the size of grains within a rock. What are the different size? Broadly, it is divided into two types. One is phaneric, another is aphanetic. What is a phaneric? Can we see it in naked eye? Phaneric is a grain size which can be seen under microscope. The naked eye be completely pocket lens. So any grain size that can be seen through naked eye or with the help of a pocket lens. You can see the grain size or grains within a rock with the help of your eye or with the help of a pocket lens, then that can be considered as phaneric. The pocket lens has a zoom of 10x, the 10x zoom. The aphanetic, which cannot be seen in naked eye, so you require a microscope. So aphanetic can be of four types. Aphanetic grain size can be of four types. Is your microcrystalline, macrocrystalline, cryptocrystalline, and glass. So among these, glass, it doesn't have any grains. Glass doesn't have any grains. So within a microscope, we cannot see any grain within a glass. But among these three, you can see grains. How we can define or how we can separate those microcrystalline, merocrystalline, cryptocrystalline? So any rock, if it is consists of microcrystalline grains, that means it has grains that can be seen under microscope, and you can distinguish the boundary of individual grain. So these three category, it is depend upon the boundary condition, whether you can define the boundary of a grain or not. In microcrystalline, you can see individual grains and you can define the boundary. So you can distinguish between two grains in a microcrystalline. There is a bound, but which cannot do in case of cryptocrystalline. So all three can be seen under microcrystalline. The grain boundary, you can say visible grain boundary, distinguished. Okay. In case of this grain boundary, not distinguished. And this thing is intermediate. That means ki partly you can distinguish, partly you cannot distinguish. In glassy, there is no grain at all. Then size again shape. Shape, it is defined as the shape of grains. Shape of grains can be euhedral, subhedral, and anahedral. All know what is euhedral, subhedral, anahedral. So in euhedral, all the crystal pieces of a grain are well developed. Subhedral, partially developed, anahedral, no faces at all. So it is, you can say, well developed crystal faces. So in case of anahedral, no faces. Subhedral, crystal faces are partially developed. You can also define the shape by using other terms like your equidimensional, prismatic, tabular. Also use that kind of term. Wedge shape, elongated. All these terms we are using during our texture. Two-dimensional, prismatic, tabular. Also use lamellar, wedge shape. All these terms we also use for the size shape of the grains within igneous rock. So these are more degree of crystallinity, size, shape. Then all these things, how they arrange within a rock, that will be actually the mutual relationship between grains. That means a igneous rock can consist of a single shape or size of grain, or it can consist of different shape and size of grains. So on that basis, you can say mutual relationship. Grain can consider equigranular, you can consider inukigranular. Equigranular means all the grain size within a igneous rock or shape will be same. All the grain shape size will be same within a igneous rock. That is called as equigranular. It will include three types: allotriomorphic, hypidiomorphic, panidiomorphic. So allotriomorphic is any igneous rock that consists of all anahedral grains. So A for anahedral, remember. So it consists of all anahedral grains. Then it is called as allotriomorphic. All the grains within an igneous rock, if they are anahedral, then that type of igneous rock is called as your allotriomorphic texture. Example, you can take applies. Then hypidiomorphic, it consists of all subhedral grains. Consists of all subhedral grains. So take the example of granite. Panidiomorphic, it consists of all euhedral grains. Take the example of lamp profile. Lamp profile is the characteristic texture. You can say it always show panidiomorphic. The igneous rock that consists of different size grain. It consists of different size grain. It will be there will be various categories. So we will discuss that under iniquity grounder. ये जो पार्ट है तो मेरा easy part. Like initially more degree of crystallinity, then more granularity, then shape, then more equigranular. After that, all type of more texture that will come under inequigranular. First, texture by two stages of cooling. Texture by two stages of cooling. It will come under inequigranular. Come under inequigranular. So during cooling of magma, during more crystallization of rock from the magma, so there may be a single event of cooling, or there may be two events of cooling, which will be different from each other. Data cooling होगा जोटे कितना? One is rapid, one is slow. So whichever is occurring fast, that will determine the type of texture. So you porphyritic texture and poikilotic texture. Those are type of texture that contain both coarser grain and finer grain. Coarser grain and finer grain. So that texture can be explained on the basis of two stages of cooling. So when there will be two stages of cooling, we will get two grain size. That we call bimodal grain size distribution. That we call bimodal grain size distribution. So when there will be two stages of cooling, we will have a bimodal size distribution. That slow cooling will produce larger grain, rapid cooling will produce smaller grain. So slow cooling followed by rapid cooling. That means first there will be slow cooling, then rapid cooling. We produce a texture that is called as a porphyritic texture. We produce a texture that is called as a porphyritic texture, where larger grains are surrounded by smaller ones. So these are larger ones. They are surrounded by smaller grains. These are larger grains. They are surrounded by the smaller one. The larger one called as phenocryst, and smaller one together called as ground mass. So it is produced due to two stages of cooling, which will create a bimodal size distribution. So depending upon ground mass characteristic, you can define the texture into two types. One is a vitrophoric, where the ground mass is completely glassy. Where the ground mass is completely glassy. Here the ground mass you can see in case of vitrophoric texture, it is completely glassy. So it is when ground mass is glassy, it is called as a vitrophoric texture. If the ground mass is a cryptocrystalline matter, that is called as a felsophoric texture. So when it is called felsophoric texture, when the ground mass is cryptocrystalline. So ground mass is glassy, it is vitrophoric. Ground mass is cryptocrystalline, it is felsophoric. In other cases, the phenocryst can contain numerous inclusion within them. Like suppose this is a phenocryst, it will contain smaller grain inclusion within it. What we call larger grain surrounding the smaller grain. Larger grain surrounding the smaller grain. It is actually the inclusion of smaller grain within a larger grain. So that is called as a poikitic texture. That is called as a poikitic texture. It can be explained on the reverse process or the rapid cooling followed by slow cooling. But it is not conclusive. But you can write down the rapid cooling followed by slow cooling. So here the larger grains are called as oikocryst. Larger grains are called as oikocryst. Unlike in case of perforated, it is called as a phenocryst. So these two type of texture, it can be explained through two stages of cooling, which will give you a bimodal grain size distribution. This is a type of poikility texture. You can see these are the larger grains where we find smaller inclusion on them. This is what we call larger grains surrounding the smaller grains. So this type of texture is dendritic or spinifex, which will have a elongate crystal. They can be formed by this phenomenon, what we call quenching. Quenching means rapid cooling. So when the rate of diffusion is slower, that means that it, the depleted region are slowly enriched. During crystallization, the nearby region are depleted because of use of iron, or if the crystal is forming from a contrasting composition magma. When the crystal has a different composition than the surrounding magma. So obviously the surrounding magma will be depleted by the iron that required by the crystal. So that's why if that diffusion is faster, then crystal will grow in there. If diffusion is slower, the crystal tends to move or tends to grow in the direction of the depleted zone. We always try to overcome that depletion zone and to reach the ion concentration region. Suppose consider here there is a crystal here. So these are the surrounding thing. So these are the neighboring magma chamber, which is from which ion is diffusing from this region. So if diffusion is slow, this crystal will tend to grow in that direction to reach out the crystal by itself, reach out the ion by itself. That's why they will form a dendritic like a pattern where they will grow towards the ion concentration zone. That is a cause which will produce a elongate crystal. That is a cause which can produce a elongate crystal, or you can say tree-like crystal, branching tree-like crystal, because it has a tendency of growth. So it required iron. So it will gradually tend to move in that direction. That tendency which कौन सा crystal produce करेगा? Slow diffusion, because the iron is diffusing this region at a very slow rate, but this crystal face energy, it has higher face energy so that it can grow larger. So because of that difference, the crystal, it tap out in that direction. It try to grow in that direction, forming elongate crystal. And due to quenching, there will be sudden cooling and sudden undercooling also. So that will also facilitate the rate of growth. That will also facilitate the rate of growth. So according to the rate of growth, the diffusion is not there, so that crystal will tend to move in that direction. Well, understood? So the example of that type of texture, you can say spinifex. It is a characteristic texture of comatite. It is a characteristic texture of comatite, because comatite, it is a magma that has a temperature of 1500 degrees centigrade. Magma having highest temperature 1500 degrees centigrade, where diamond is a xenolith. So as it has now 1500 degree temperature, anything that will be cooler from this ultramafic rock or your granitic. So when it come in contact with other rock, then it will be quickly cooled. It will be quickly cooled by what we call quenching. Because of quick cooling, there will low diffusion rate. It will produce elongate crystal, which will look like a bunch of grass. Look like a bunch of grass. एमती देखा bunch of grass, घास देखो ना नहीं. So it is also formed in a very low viscosity magma, so where the growth can be proceed in that direction, where the diffusion rate is slow. Diffusion rate is also depend upon viscosity and also depend upon ion concentration. Due to this type of cooling or quenching, the other type of texture also form. This is just spinifex texture, which just look like a bunch of grass. It comes to nucleation at preferred sites. So during the nucleation can be of two types. One is homogeneous nucleus, another is heterogeneous. Homogeneous nucleation, heterogeneous nucleation. So homogeneous nucleation means any nucleation that form from the melt, or they are forming a cluster that is homogeneous. Heterogeneous occur when any nucleation that preferred or that occur on a pre-existing mineral. On a pre-existing mineral. Suppose if see we have this magma chamber, we have ions here, and also some crystals is already formed. So clustering can occur here, it is within the magma, or clustering can occur on a pre-existing crystal. Clustering can occur or nucleation can occur on a pre-existing crystal. So that is that we use the term epitaxis when nucleation occur on another crystal. So if another crystal on another crystal clustering is occurring, if this cluster and this crystal they have different structure, then it is heterogeneous. It is heterogeneous. If they are same structure, they are homogeneous. So because of this growth of one crystal over another, it will produce some type of texture. That is called Rapakivi texture, perilytic and virulitic. So epitaxis, that a term we use to describe the preferred nucleation of one mineral on another mineral, or nucleation of on a pre-existing mineral. So growth of tomorrow you can say sillimanite on biotite or moscovite in metamorphic rock is one example of epitaxis. Here in the case of igneous, the Rapakivi texture, which is a type of texture involving the growth of plagioclase overgrowths on orthoclase. When K feldspar already ଥିବ ତାପରେ के produce होगा albite है ना नहीं. So involving plagioclase overgrowths on orthoclase, typically found in some granites, especially between K feldspar and oligoclase. But the plagioclase preferentially forms on the structurally similar alkali feldspar. That means it has it is a homogeneous nucleus. With the K feldspar, that this plagioclase or you can say oleoclase, it is growing over the K feldspar. So K feldspar and plagioclase is growing like this. This is your Rapakivi text. You can see here also K feldspar, what we call K feldspar mantled with oleoclase. K feldspar mantled with oleoclase. Then another texture, that is periodic texture, that is also formed by epitaxis process, where silicic volcanic rock, that is more quartz and alkali feldspar, they will grow needles like. They will go needles like this from a common center. So these are the textures that form during devitrification. Devitrification, it is the process of conversion of glassy matter to crystallized matter. So during that, on epitaxis condition, spherulity texture will form where you'll find radiating alkali feldspar and quartz grains from a common center. This type of texture is called as a spherulitic texture. Then another is virulitic texture. It also consists of radiating plagioclase laths in basalt. That is also because of epitaxis, where you will find plagioclase laths on basalt. So it is also formed during devitrification of glass. So mechanism is same, it's depletion of one mineral on a pre-existing mineral. Virulitic, spherulitic, and Rapakivi. Another type of epitaxis textures are sometimes nucleation of minerals can occur on dike. You will find that ladder vein type of texture, ladder vein type of structure. That is also nucleation of economic mineral or other mineral on a dike. And you can also found crystallization within cavities, within cavities. That is in case of tomorrow quartz, what we call geode. What? Geode, where the quartz has a cavity. That cavity can be filled with solution, which can grow form a comb structure. Can go from a comb structure because the growth of crystal always start from the wall to the center, and the crystal always project from the wall to the center. So it look like this. It look like comb. So that's why these are called a comb structure. So it look like a comb. Around. Similarly, another type of texture that is crash cumulate, which tend to duplicate on the wall of the fracture or of the fissure. Wall, generally it is found in layered mafic protons on the margin of granite. Compositional zoning. Zoning it is found during solid solution. Where if in equilibrium happen during solid solution, it will produce zoning. So compositional zoning is common when occur when mineral changes composition as it grow during cooling. It is achieved because of inequilibrium crystallization. So during the crystallization of suppose albite and anorthite, if there is inequilibrium, then during crystallization initially it will produce calcium rich member. Initially it will produce calcium rich structure. Then after that there will be sudden cooling. Then all the sodium will surround the calcium. That is your zoning. So during zoning, it actually continues like this. Then again sodium, then again calcium, then again sodium like this. Which once in equilibrium achieved during this albite anorthite crystallization, so then re-equilibrium is very difficult to achieve because it involves more SiO and ALO both bonds. So during in equilibrium, these two bonds will break. These two bonds will break. So again to form these two bonds is very difficult. So that the zoning continues. That's why we will get oscillatory zoning. Is that common? Oscillatory zoning. That's why it is also very common in albite anorthite case. So compositional re-equilibrium, it requires for SiAl exchange and it is very difficult to the strength of SiO ALO bond. So because of the strength of the SiO and ALO bond, it is very difficult to achieve the re-equilibrium. So that's why you will find zoning, oscillatory zoning is very common in case of plagioclase. Any rapid cooling that will produce an inequilibrium. Visual like this with zoning. The calcium member there, sodium. When it comes to crystallization sequence, crystallization sequence. So that you will find uvetral, subatral, anhedral. There is a rule that the early forming minerals in the melt are not significantly undercooled during tomorrow less degree of undercooling. There will be low depletion rate, so the growth rate will be high. So remember that diagram, rate of growth and rate of depletion. In that case, if you do less degree of undercooling, you will get well developed crystal. As you do more degree of undercooling, the crystal will become subatal, then it will become anhedral. So that is a general sequence. There is a general sequence That euhedral crystal will form first, then subhedral, then anhedral. It's not completely true always, but it can be considered as a sequence. So because of that, the low intercooling will produce larger crystal. Then as you increase the intercooling condition, then you will get subhedral and anhedral crystal. So also the euhedralism that diminishes in the order of increasing of SiO polymerization, because during SiO polymerization that increase the viscosity. Increase the viscosity. That's why the crystal will form that will gradually form anhedral. That's why olivine and pyroxene tends to more euhedral than quartz and feldspar. It is general statement, but latter stage because of more addition of volatile or addition of more water, they can produce well developed crystal. So in that example, the example is a pegmatite. So it form on the latter stage or at the end stage of the crystallization, but still that will form larger crystal. So these are general statement you can say where euhedral will form fast, then subhedral, then anhedral. Otherwise, your euhedralism depend upon the SiO polymerization. That means olivine has gone zero share of tetrahedral, then pyrazine share two of its oxygen, then amphibole, then biotite they all share three of its oxygen, then K feldspar they share four of its oxygen. So the linkage increases from down the series in a bound section. So linkage as the linkage increases, the viscosity will increase. If the linkage increase करो तो कहाँ? The viscosity will increase. So viscosity that will block the flow, or that will block the diffusion, that will reduce the diffusion rate. So crystal cannot grow to larger, or sometimes there will be no crystal at all. So crystal growth more also depend upon surface energy. Mineral with very low surface energy may form euhedral crystal, because if you have low surface energy, that is more stable actually. High surface energy tend to grow larger, but those who have low surface energy, they are more stable. They are more stable. Their crystal is more stable. So that if they have for any mineral or crystal has low surface energy, it will form more euhedral crystal, more euhedral crystal than high surface energy crystal. Surface energy is energy how that lattice or that ion in that surface adding ion to it for further growth. If it is a higher surface energy, it can add more crystal, but it will be always unstable. But low surface energy, because of their low energy, they are very stable. So that's why if tomorrow low surface energy achi, then it will always tend to produce a euhedral crystal. क्योंकि garnet starlight, like if they are euhedral, zircon, apatite, titanite, they tend to be euhedral. So because of their low surface energy. So these are a general crystal sequence. Segment are always की difficult कि तुम्हें कोई भी which crystal is produced fast, whether larger one produced fast, whether the smaller one produced fast. In case of porphyritic texture, we use कि larger can produce fast, then smaller can. But in case of coagulative texture, we are considering smaller can form fast, then larger can. So that's the example of coagulative texture or phytic texture. Phytic texture where plagioclase and chylopyrrhizin they actually grow simultaneously, where plagioclase are larger or smaller. Plagioclase larger, obviously larger no smaller ही होगा. So plagioclase is surrounded by parison. So it is a poikilitic texture. Ophitic is a poikilitic texture. So clinoparisians are larger, plagioclase are smaller. So actually they form simultaneously, but they have different grain size. Also, you can explain granophyric texture will not obey the grain size sequence or crystallization sequence, where there is a intergrowth between alkyl feldspar and quartz. Alkyl feldspar and quartz. So what happens during crystallization of H2O rich granitic system? Volatile rich granitic magma, where the single alkyl feldspar will form fast, then from H2 granitic system, fast alkyl feldspar will form, then quartz will form in H2O rich condition. But if suddenly the H2O is lost, then what will happen? If suddenly H2O is lost, the melting temperature will rise. Also, the melting temperature of quartz will rise. That means कि now it is able to crystallize. এটা କହିପାରିବ? Crystallize it. Suppose कि you consider the H2O rich magma, K feldspar and quartz. So it is at a temperature of suppose 700 degree or 600 degrees. Suppose. So now K feldspar will crystallize. If H2O will lost, then melting temperature will rise. Also, the melting temperature will rise. That means the crystallization temperature is rise. That means this temperature will remain constant. It will not change. Temperature will remain constant. Only these things will affect that quartz. Its melting temperature will rise. That means along with K feldspar, quartz will also crystallize. Along with K feldspar, quartz will also crystallize. So there will no time for formation of independent crystal. Because of when H2O is released, that means it is a rapid cooling condition. It is a rapid cooling condition where K feldspar and quartz they cannot form individual crystal. So they will form an intergrowth between them. They will form a intergrowth between them, quartz and feldspar intergrowth, what we call a granophyric texture. Quartz and K feldspar present ଅଛି H2O ଅଛି. Then to crystallization first from K feldspar, then quartz general sequence. But यदि H2O loss होगा, H2O loss होने कौन? Addition of H2O decrease the melting temperature. So loss of H2O increase the melting temperature. Melting temperature increase करियो meaning कौन? तो 600 डिग्री टेम्परेचर रे अच्छी सिस्टम टा quartz crystallize होगा 573 डिग्री. That is its melting temperature, also freezing temperature. The freezing temperature melting temperature increase होची meaning कौन? Suppose कहली 573 degree, it is the melting temperature, also freezing temperature of quartz. तार increase करियो माने कौन? 600 degree ही जो 700 degree जो कौन था? Melting temperature and freezing temperature. Understood? हाँ, देखो तो कुछ presence of water decrease करो. जितने water टा पड़ेगा, तो एबे तार melting temperature बढ़िबो. तो ए concept टा बुझ पाछु ना कि melting temperature increase करियो माने it can crystallize at higher temperature. से higher temperature रे crystallize कर पारी. बुझे ना? যদি তুমি H2 add করছো তাহলে সে lower temperature রে পাউছি melt कर देउची বা crystallize होची. सेंती से higher temperature रे crystallize करिवो और melt करिवो. Suddenly H2 lost होची ता माने quartz melting temperature will increase. Further, melting temperature will increase or freezing temperature will increase. Increase kala mane now at that temperature, it will able to crystallize itself. So कौन कर पारो? Crystallize ही पारियो ना नहीं? तो सेट में कि also rapid cooling हमारा H2O rapid cooling में sudden cooling से type रहुची कि cooling rate is greater. So H2O lost होची so that it quartz and K feldspar crystallize होचंते. When individual crystal formation होती sufficient time लगता है. Yeah, sufficient time लगता है सबसे ते माने intergroup produce होता है. ସେଟା କାମ କହନ୍ତି ଗ୍ରାନୋଫାଇରିକ୍ ଟେକ୍ସଚର it always produces ସେଥିପାଇଁ ଗ୍ରାନୋଫାଇରିକ୍ କଥା କାହିଁ କୁହାଯାଇଛି because ଗ୍ରାନୋଫାଇରିକ୍ produces କ'ଣ smaller grain ଗ୍ରାନୋଫାଇରିକ୍ actually କ'ଣ it is a micro texture so तुम्हारा intergrowth between quartz and alkali feldspar we call graphic texture ହଁ graphic texture but the finer variant is your କ'ଣ granophyric it is formed by this process. So read the process and if you have doubt then ask me. Then go to reaction texture. So these are the texture that develop during the reaction of aliform crystal with the magma. Sometimes the crystal that form from the magma it will react with the magma at certain temperature, but we always call peritectic temperature. Common peritectic temperature. Example reaction of olivine with melt to form pyrogen. Okay, the form at the peritectic temperature. So use the term resorption. Resorption again remelt होगा. The aliform crystal again react with the aliform magma or melt and it will again melt or again into the solution. That is called resorption. And another type of reaction that occur when magma reaches to the surface, when it will reach to the surface, it will release the volatile. Because pressure will release, all the volatile will be released. So that will, in case of sudden loss of pressure, volatile will release. That will cause hydrocyanocrisis, hornblende, biotite. They all will dehydrate. They all will dehydrate, and after dehydration, they will form a rim of oxides due to weathering. So during the reaction between the aliform crystal and melt, the reaction is complete, then this crystal will completely dissolve completely into the solution. Sometimes the reaction is incomplete. Sometimes the reaction is incomplete. That means the reaction part it will appear like a rim around the mineral or around the aliform crystal. That is called as a reaction rim. Two types of reaction rim. One is a corona, the reaction rim formed by the reaction of aliform form with the primary magma. And if a crystal it is reacting with another type of magma from which it is not formed, then it is secondary magma, that is caliphatic border. So reaction rim can be called as corona, can be called as caliphatic border. The reaction rim formed by reaction of aliform crystal with a secondary magma, that is caliphatic border. If it is react with the same magma or primary magma, that is also corona. So during flow of magma तो कोई lava कहते हैं. During flow of lava there are differential movement. Differential movement, some will flow faster, some will flow slower, some will flow cluster. So that type of texture that formed during flowing of magma. So flow within a melt, it can result from alignment of the crystal, that is simple lineation or foliation. If lathe shape means thread like shape, micro lights, like typically plagioclase, that we call laths of plagioclase. So laths of plagioclase in a volcanic rock, they can arrange themselves in the flowing direction parallel to each laths. They will parallel to each other. They will arrange in a volcanic rock, which will slow a flowing condition also, which will slow flowing condition of lava flow condition में indicate करें. That type of texture is called as a trachytic texture, where the laths of plagioclase in volcanic rock are strongly aligned, like commonly flowing around the phenocryst, aligned or flowing around the phenocryst. They will be like this, or they can be like, they can surround the phenocryst like this. Okay. So this type of texture is called as a trachytic texture. If the laths are randomly oriented, randomly non-aligned microlights or laths of plagioclase, in that case we will call it as pillow texture or felty texture. Sometimes they will align themselves during sufficient of flow. If there is no flow, then they can arrange in a random fashion. They called as pillow taxis. And if there be mixing of two magma, they can form banding. That is called flow banding. Suppose acidic magma, basic magma, they are mixed, they can form flow banding because of contrasting composition. And during flow, crystal or laths or crystal, they can cluster together. They can cluster together. So that is called as your syneiosis. Syneiosis is your clustering of crystal. तो जिनसे जो जाऊँ कौन क्लस्टर है ड्यूरिंग फॉर फ्लो तो नॉर्मली रिवर वगैरह तो देखती हो कि क्लस्टरिंग ऑफ कि मोइल जो जिनसे जाए फ्लो करे कि waste metal price they cluster together during one flow. Similarly, during flow magma, crystal can cluster together. Crystal का clustering है. पिलकुडूरा देखे ना cluster है तो देखेंगे. So clustering will produce a texture that is called as cumulophyric or glomeruloperpetual. There are multiple grain cluster. Cumulophyric. That means it involves different type of grain or different type of crystal. That is a cumulophyric texture. That means during flow, if crystal is forming clustering, and if that cluster consists of different minerals, then cumulophyric. If that cluster consists of a single mineral, it is called as glomeruloporphyritic. Then come to cumulate texture. Sometimes the aliform crystals react with the magma, sometimes they will not react with the magma. They can settle down like a gravitative settling. So they will form a texture that is called as a cumulate texture. So these are type of texture that are formed by aliform crystal. So the aliform crystal, if they have no reacting nature, like dioxide anoxide case, where dioxide is the aliform crystal which will not react with the magma. It will float on the magma or it will settle to the bottom. It will form cumulate texture. So the fluid in between the aliform crystal, these are called as cumulus. Sorry, crystal is called cumulus. The fluid is called as the intercumulus liquid. The fluid within the, so these are cumulus crystal. The fluid between them, they are called as intercumulus liquid. So there are three types of cumulus texture: one orthocumulate, one adcumulate, one mesocumulate. That on the basis of how with crystallization they are growing, how the intercumulus liquid are crystallizing with progressive crystallization. Aliform crystal, it will produce the intercumulus liquid in between them. Then with progressive crystallization, the intercumulus liquid will start to crystallize. Intercumulus liquid will crystallize. There will be three conditions. If the intercumulus liquid will be separated from the aliform crystal, it is ortho. If intercumulus liquid will show an overgrowth with the early crystal, it will add cumulate. If it is intermediate, that is Uchi major cumulate. So, if the liquid crystallizes is essentially in place without exchange with a larger magma reservoir. So, if it will exchange with a larger reservoir, then it will flow over the aliform crystal. So, it has a chance that it will flow over the aliform crystal. Suppose you have aliform crystal like this. These are the fluid in between them. That is called as intercumulus liquid. देखो गया intercumulus liquid. So with progressive crystallization, the intercumulus liquid will crystallize. So when intercumulus liquid will crystallize, they can crystallize like this. Suppose कि these are crystallization of intercumulus liquid, they will crystallize without being in touch with the aliform crystal. If these intercumulus liquid are exchanging ion with the neighboring magma chamber, they are exchanging ion with the neighboring magma chamber. So during flow, they will crystallize over the they will crystallize over the aliform crystal. So because of this ion exchange, the intercumulus liquid will show an overgrowth on the aliform crystal. So it is occur essentially where there is without exchange of the larger magma reservoir in the interior of the chamber. There will be no exchange. In that case, the crystal will produce, it will be separated from the aliform crystal. So that is called as your orthocumulate. Hard cumulative interstitial liquid can escape and exchange material by diffusion and conversion with the liquid of the main chamber. The aliforming cumulates may continue to grow as rejected components in the interstitial liquid escape. The result होची hard cumulate. जोटा हम कहले कि during तुम्हारे exchange, your crystal may grow over the aliform crystal. So that is होची का? That is होची hard cumulate. If they will remain separately without any exchange, that is hochi orthocumulate. And intermediate is your mesocumulate. They are partially overgrowth and partially separate. So these are the aliform crystal. They are showing overgrowth like this because of the exchange. What is X solution texture? Replacement. X solution texture is a type of texture that form when the liquid are mixable at higher temperature, but they are separable at lower temperature. That's why name is given to X solution. You can take the example of albite and orthoclase, but they are mixable at high temperature, but they will separately crystallize. Miscibility gap. Here they will form anorthoclase. but at lower temperature they will be separately crystallized. They will not mix with each other. That is called the X solution texture, where crystals or liquids are mixable at higher temperature but will separate at lower temperature, forming separate solid. The result of X solution, the texture called as porphyrite texture produced. Porphyrite is in between albite and orthoclase, where K feldspar greater than albite. Then antiporphyrite, albite is then mesoporphyrite, I mean, depend upon the initial composition, but of the mixture of liquid, if K feldspar is dominant in the liquid, then obviously K feldspar will be more. K feldspar अधिक ଥିଲେ K feldspar ଅଧିକ ହେବ, albite ଅଧିକ ଥିଲେ albite ଅଧିକ ହେବ. It is a type of texture that form in metasomatism process where there is a tectonic activity. That's why it is distinguished from graphic texture. It also involved myrmekite also involved the intergrowth of quartz and feldspar. Quartz and feldspar. So in that graphic case, we use orthoclase. Here we use plagioclase. The vermiform quartz are present over plagioclase. Vermiform, it is the worm-like. Uniform due to more metasomatism process. Alkali metasomatism. So during the flow of magma, elongate crystal can cluster like this to form a polygonal or triangular shape. So they will enclose a space between them that is called as a mesostasis. It's called as a mesostasis. That mesostasis sometimes filled with grain, sometimes filled with glassy matter. If the mesostasis filled with grain, it is filled with grain, then it is intergranular. If it is filled with glassy matter, it is intersubtle. It will come under flow texture.